In robotics, there's two different schools in robotics right now. Top-down developers who are trying to make robots like people and look like us, mimic us, interact with us. And then the other school are people like me who are called bottom-up builders, and we're trying to make robots that are modeled after other things. When I think that we should maybe try to use robots to improve on us. I don't actually think that our arms and legs and the way we move are the best for function in robotics, and so I think I think people that are trying to mimic us and create robots like us, I think it comes from the idea of ego, that we could create something like us or in our image, and I don't like that, or I don't agree with that.
My name is Robert Serrano, and I'm really just kind of like help on the robot, anywhere from like soldering parts together or wiring something up to programming little parts for the robots or tiny things like that. But we want it to be an autonomous robot that's capable of sensing its surroundings, being able to pick up on information that we send in, and then act on that information. Whether it be anywhere from like repairing something, like broken down buildings or places that human beings really shouldn't be at, the robot could do all of that. So we have the 4 legs that give it the ability to walk, and then we have a pivot ball to give it some sort of stability. And then, I mean, right now it's really like, it's a prototype. We just want to get it walking, and then we can start to build off of it, off of a lot of the ideas a lot of us have had. Well, the first idea is like a mantis, a praying mantis. They're pretty sound insects and pretty strong. I mean, their snappers are pretty incredibly strong. So we try to mimic it or model it after the praying mantis.
Insects, very efficient. Their motions, the way they move, are very easy to mimic in robotics. And then the praying mantis, because he walks on 4 legs, but he has these 2 big mandibles up underneath. So when my robot is done someday and that head rises up, he'll also have arms that can come out and reach. So he actually has a long way to go. Right now he has the 4 legs and the big head. But yeah, the mantis is a very versatile creature.
Mantis, the arms are really a good modular idea we wanted to have. So we could have we could use the, what would you call it? The advantages insects and arachnids have as far as being able to have multiple joints and cover long spans of areas and an amount of numbers. So the mantis, I guess it's like adding a human torso to the top of it. So that way we could have, this thing could like climb over rocks or, go over these really big obstacles, and yet at the same time still have this ability to have dexterity wherever it needs to be.
The first thing is understanding how stuff moves, how a joint moves, or this, or this. That's what I started thinking of when I started looking at the bug, and then I literally got down on my 4 legs and started seeing, okay, how does my shoulder pivot? And how can I mimic that motion? So for me, hands-on design, literally taking pieces and holding stuff together and moving parts, was how I figured out how I could make that robot move. And then I have a lot of experience with radio control cars, planes. I've been building boats, planes, cars since I was a little kid. And so then once I knew how I wanted the robot to move, then I knew how to put servos in the joints to create the motion. So that's why he's based on servos right now. And so we're using little motors to make the motion, and then I'm just using very simple motion for movement. Right now, base that he has, his 4-leg platform that he's walking on, will be able to navigate a room, and it has a program that we're designing to be able to get out of a room, so he could find his way out of a room. And then he has the head that rises up and has a camera on it, has a GoPro camera for surveillance. And then he also has a laser beam rangefinder on him that we could ping an object and tell you how far away it is. So right now he is built for surveillance, would be the first basic application of what he can do, land-based surveillance.
So yeah, anywhere from being able to repair buildings to because we had the idea that it was a robot that you didn't bother to have. It was where you didn't want human beings at, old decaying buildings, mine shafts, all these places where you don't want to lose a human being's life. So with these things, the idea would be the strength in numbers would give us the ability to use as little human beings as possible, but use the best amount of, or the least amount of resources for the robots themselves, whether it being actual energy use, communication-wise, and then so that's why our first prototype is where it's at right now, so we get a base standard model, and then we get to make it modular in the sense where one robot would be sort of like a general or dictator towards smaller robots that wouldn't cost as much, and parts would be. So we have these categories we built for the different levels of how complex the Mantis robot can get. So if it's we just need them to spray foam to fill in some hole, it's not going to be very complex. It's find the gap and then fill. But things like you need to go in, find out the rooms, scope it out. Those are things that are a bit more expensive. So with the idea though is if we can handle these big, so if you have a building that's slowly crumbling, instead of having a few set of people try to figure out exactly how to do it, you send the whole wave of robots that have their algorithms for communicating, to make it easier for all of them to cut back on all the small amount of the little nuances that we would have to go through, and that way they can think about it as a team and a well-distributed team, and then get it done in the least amount of time, as safe as possible, all that kind of stuff.
So I started working with 3D printers about almost 3-4 years ago now, and my son actually built our first 3D printer. And so I took that and started learning how to program and build stuff on 3D printers. And then once I realized how valuable a tool it is, then I bought a nice 3D printer, a high quality 3D printer called MakerBot. And then I learned for the last 2 years a modeling program to be able to actually design parts and create images in. So I have about 3 years now of just working on my own, developing my skills just to be able to work with my 3D printer. But now that I have these capabilities, I feel like I can make and prototype almost anything. So the idea of the robot, his arms, his legs, any piece that I can think of, I go straight to my modeling station, design it there, and actually look at it in a 3D virtual space and see how I like it and assemble it and see, oh, is this going to work? Or no, this looks weird, or it's not going to fit right. And then I can modify it, change it before I ever print anything out. So that's really exciting. It saves a lot of time, material. So that's how I was able to develop him so quickly. Yeah, he could actually take years but just 5 years ago, without a 3D printer involved, he could have taken 2 or 3 years to build him. The electronics department enters projects in the state fair every year. So I think it's a pretty good ongoing tradition. And last year we had a booth set up, and a robot that I built last year was just on exhibit, and just the way I saw all the kids and people interacting with my robot kind of motivated me to want to do more. So pretty excited. A lot of people are going to come and see it. As far as excuse me, as far as what we'll gain right now, maybe there are some awards that they give out at the state fair. But I really think I was using it more as a platform to take me to a university to keep the project going.